after the lunch, but I will try to make this session interesting so that everyone can learn from each other. So today I am giving this session on infrastructure as API, the secret ingredient to your platform engineering efforts, because I myself work as a lot in infrastructure as code, GitOps domain, a lot of cloud infrastructure, but I have seen like a change in this domain from infrastructure as code to something more scalable. So I wanted to share my knowledge on some new tools and some new like patterns that are emerging in this platform engineering domain. So anyone who is working a lot in DevOps or platform engineering stuff might be able to relate with this session. So let me just start. Okay, so let me just try and address the problem statement first, which is something that everyone might be able to relate. But can I get like a show of hands of people who are working in infrastructure as code or something similar, or even configuration management? Okay, so thank you so much. So the thing is, a lot of the people might be able to relate to this. Like there is a scrum call, I think, in most organizations, and generally the problems is discussed by the business team that prod is down, and then there is a hustle between the dev team and the operations team a lot of the times, in which the dev team comes up with the thing called works on my local. I don't care about what happened in the deployment, so this is not my problem. And then the platform team, or if I talk traditionally like the sysadmin people, or then it evolved to DevOps, today SRE or platform engineers work late nights to resolve the issue. But if you observe the issues, most of the time, if you do root cause analysis, most of the time you will find that the issue is something which is related to configuration drift. For example, you are expecting some other desired state, but there is some other desired state. So over my experience, I discovered that most of the problem can be resolved by using some tools and some methodologies which can solve this. So for example, if you start managing all your infrastructure and configuration in Git, then Git becomes your single source of truth. So GitOps was a huge shift over DevOps, which fueled DevOps in my opinion, and even platform engineering. So there are two tools which are prominent in all the DevOps workflows right now. Like I see a lot of usage of two tools, which are like all the tools here can be used by different DevOps teams, like depends on the organization totally. But some of the tools which I find doesn't sit well with DevOps are Terraform and Helm. So why I say that big statement is because while the idea of IAC was to bridge the gap between the developers and the operations team, it doesn't scale very well, in my opinion, because if you traditionally think about IAC, infrastructure or configuration was always used to be maintained, like it was like maintaining numbers. So traditionally sysadmins used to have Excel sheets in which they maintained servers, IP addresses, and then maybe these are the applications running in those servers. It was always a numbers game. It was always a maintenance job. But in the name of like shift left, we started using code to define our infrastructure, which was good in the first place. Why shouldn't we read? Because you get a lot of engineering to do with it. Like you can implement your control loops, your logics, all your patterns, programming patterns, right? But if you really think about it, from the Kubernetes point of view, Kubernetes was built on the idea of the promise theory. If you know, like desired state. I don't tell Kubernetes how to run a container, right? I just give it a desired state that, boss, I need 2 containers running in my machine, and Kubernetes handles all the reconciliation, all the control pattern, everything for me, right? So if and that is the approach we follow for our apps, for our application, for our workload, why don't we follow the same approach for our infrastructure as well? Because infrastructure is defined using code, but application is definitely being done using Kubernetes or similar container orchestration tool. So that is where I started looking out for another solutions in the market. So because these were some of the problems that I faced, I already discussed these. Yeah, also one more important aspect is in platform engineering, one of the major principle is I start looking from whatever work I do, not from the just doing a work, but I start like implementing reusable APIs for me, right? So that I can implement some logic, maybe define an infrastructure as code module, and then give them as a service to other teams, developer teams or other teams, so that they can use it, right? I don't want to constantly work in something, because I want to create reusable services for other teams, because developers are our core customers if you think from platform platform point of view. So in 2025, I see that infrastructure as code doesn't actually integrate well with the platform engineering principles, which is why we are going to talk. I think I will discuss about why it doesn't sit. So infrastructure as code has a lot of complex logics in it. It has a lot of control loops. You can implement your own conditionals, loops, and everyone's idea of writing code is different. If you compare to Terraform engineers, they will define their VPCs, EKS, subnets in a very different way. Some will use some other, because it's codes, it gives you free ability to be creative and write your own infrastructure as code. So the work done by one DevOps engineer may not be able to be used by other DevOps engineers because everyone has their own idea, and this creates configuration drift and maintenance becomes hard, which is where I see it doesn't integrate well with platform engineering because of the desired state thing also. So let's look at some of the other options we have in. Sure. Okay, sorry. Yeah, so some of the other options in the market, what are those? We can have a look, what are the available options. So one of the first tools that I started using in this, looking out for a change from Terraform was actually Cluster API, if you know. It's also a Kubernetes maintained project, but that was only limited to Kubernetes. So I started, but as infrastructure is more than Kubernetes, right? It's lots of S3 bucket, RDS instances, a lot of things, right? So that's where I discovered another tool from an organization called Upbound, but donated to CNCF, which is Crossplane. So what Crossplane does is it lets you define your control loops, your control planes, and you can define any kind of control plane which consists of all the infrastructure that you want to create, and then provide them as a service to the dev teams to consume. So and then there are some recently AWS announced this tool called Kube Resource Orchestrator, CRO, which is also built on the same principles like Crossplane, but from Amazon, so better branding, I will say. And then it also helps you define your infrastructure, and it has control loops implemented for all of them to be created from within Kubernetes. And earlier there used to be a tool called ACK. Right now it is not much maintained, which is like just Kubernetes controllers for AWS. So you can create your own S3 bucket from Kubernetes. You can create your own EC2 instances from Kubernetes. That is also similar philosophy, but yeah, vendor lock-in, limited to AWS. So Crossplane is right now my tool of choice because of the maturity. And I will talk about the benefits. So yeah, the first point is one of the core benefits I saw which helped me transition to Crossplane, which is the distributability. Like with Terraform, you are always writing infrastructure as code and then maintaining it in a Git repository or somewhere and then shipping it. But with Crossplane, since you are just handling data, you are writing YAML manifest, which is a language to define data. You can package them in form of artifacts. So just like if you see what Docker did for like environments, right? It helped us with a way to define our environments and everything needed for our applications to run and ship them as binaries. So Docker images, you can store them in repositories. Similar thing Crossplane did. Crossplane created, lets you define a way in which you can define all your data, which is your infrastructure, package them as a artifact, tarball maybe, and then you can ship them to other teams and they can consume, other platform teams. Another is the abstraction. So platform is all about abstractions. So you can hide the complexity. So for a platform team, I can implement all the security best practices or cloud cost optimization best practices and package them all as a binary and then provide them to the developers to consume. So they can, while they have the ability to create their own infrastructure, they don't miss out on any of the, because you can't expect developers to have like 2 years of experience in networking and 3 years of experience in security, but you still want them the ability to create all this stuff, right? So that is why it enables like a separation of concern between the dev and the platform team. So that is one benefit. Also, there is the huge benefit of active reconciliation. So if you see, Terraform is a different API than Kubernetes. So there is no control logic. There is no controller pattern watchers and all those stuff. While Kubernetes has it, so we should use it to our advantage. And whatever you create with Kubernetes is not a one-time thing. It's not fire and forget. It's more like fire and watch, because you asked a desired state, and it will be, not only it will be achieved, but it will be maintained even when you log out. So less number of on call after 7 or after that sort of things. And then you can have this common API. Previously, we, like today, Kubernetes is by far the most preferred way to run applications workloads. But here now you're also managing your infrastructure using Kubernetes. So that gives you the unified capability to manage your application and infrastructure with the common Kubernetes API. The I think the best used API in the market right now. Yeah, this is the Terraform workflow, the general Terraform workflow, which has these some of the problems. So yeah, eventual consistency is not a pattern in Terraform, because you just ask current state to Terraform and then you just do Terraform apply. But what happens if somebody goes to AWS and downs one EC2 instance, or there is some crash in something? Until you run Terraform apply again, or you have made a pipeline based on some cron job, it will never be reconciled. So that is one problem, which is why you also face configuration drift. There is the lack of control loop, which I already discussed. And yeah, you have to create, like there is a lot of work. You have to create a lot of pipeline. GitOps avoid all the pipelines. So with Kubernetes, GitOps comes into the picture. That is lacking in Terraform. Okay, so in Crossplane, what we do is we extend the K8s API. Now, that might sound like a lot of developers' job, like writing a Kubernetes controller will be messing up with the Kubernetes API, doing a lot of logic, and then, but Crossplane is also a way to extend Kubernetes. It lets you create new custom controllers, but in a lot less complex way, which is ideal for platform teams who are traditionally not developers, who are more like DevOps engineers transitioning to platform roles. So that is why I like Crossplane. Yeah, this is the general Crossplane view. So in this, you can see that there is a separation of concern between the app team and the platform team. So on top, you have the app team whose only work is to create the application or claim it. There is a terminology in that which is called claim. So they have to just claim a resource from the platform team, and the platform team job is to implement some resources which are composite resource definition, which is nothing, which is similar to custom resource definition in Kubernetes, but it's a Crossplane terminology. And then you have a composite resource controller also. Yeah, and then you finally create a composite resource which is similar to custom resource in Kubernetes. And this composite resource is called composite because it consists of a lot of infrastructure. So every infrastructure is a managed resource. So let's say, consider the example of a EKS cluster. A EKS cluster will not just be the control plane. It will have a lot of things like the VPC, the subnet, networking, route tables, and a lot of stuff. So everything will be a managed resource in AWS, which will be managed from the Kubernetes API. So that is the idea behind Crossplane, which enables the separation of concern between app and infra team. Yeah, okay. Yeah, some of the platform engineering codes which are relatable if you start doing using Crossplane are these. Okay, so how I have used Crossplane is I have explored Crossplane and used it in one of the use cases in which this is a project called Open Source Mano, which is a orchestrator for building and running 5G networks. So to run 5G network, you actually need to create some infrastructure which is like Kubernetes cluster today, and then you have to deploy some 5G network functions on it. So previously it was not using any infrastructure as code tool, but today it has been using Crossplane because it helps it to bring, this was a purely network orchestrator which is running 5G network, but today it is a general purpose orchestrator which is building and running any infrastructure application. So as you can see, the open source Mano contacts the GKE for creating Google Kubernetes Engine clusters, AKS for Azure. So you can choose your own provider. It provides you vendor neutrality because Crossplane has provided for all three major clouds and some other smaller players also like DigitalOcean and Civo. And yeah, this is one of the use case. The other one, which is more relatable to the platform engineering team, is this one, which is like IDP implementation. So IDP is the final objective of any DevOps or platform engineer. They want to create a portal which is consumable by different dev teams. One of the use case I saw in my team was a lot of the teams, testing teams and dev teams were asking me, can you create a Kubernetes cluster for us? We need to test. And I had a Jira ticket on which I took like 7 days or something. And then they were stuck with their work, right? So a better way is to provide them a portal which they can log in and they can request a service and they can get it serviced within a day or two. They can work simultaneously, which brings in the shift left approach also. So for that, I created this cluster vending machine, we should say. So in this, some of the cross-plane resources I have created are the composite resource definition, which is nothing but it is from the business point of view, it will define what is the API looking like. So for example, if you need a Kubernetes cluster in AWS, then these are the 4 information you need to give, like node, node group, the node size, the region, and the Kubernetes version maybe. You can decide whatever because it's fully customizable. If you think that maybe some VPC, subnet, CIDR blocks are also a required information, then you can add that also in that. But usually we need to abstract away this information because dev teams might not be best to calculate the CIDR block because that is some networking best practices or some other, like what are the roles you need to add, IAM roles. Security team might suggest the best one. So we can avoid all these abstractions in the platform team concerned and just expose the required stuff. Like mostly Kubernetes version will be changing, AWS region will be changing. So those stuff we can show to the developers and others we can hide. So for this, you need to create a composite resource definition. Then you have to create a composition which will consist of all the managed resources. And finally, the dev will create the composite resource, which is the, it's like the first object of that class, first instance of that class, which actually creates the Kubernetes cluster. And I show on top the approach to package all this and make it redistributable is by creating a configuration package, what we call as a configuration package. It can just be a tarball and push to ECS or any ECR or any container registry of your choice. Similar to what providers are also today distributed in form of these packages only. It's just like a Docker image. And as you can see, as soon as you create this composite resource, it consists of so many things in the Kubernetes realm, which is like managed resources, VPC, subnet, the internet gateway, NAT gateway, route table, some node groups, and then the cluster, the control plane. But still in the Kubernetes realm, this is not in the AWS, but there will be a control logic running continuously, which will translate all this stuff into actual AWS resources. On the cloud, it will hit the API, and also it will keep hitting the API after a certain reconciliation period, and it will create a VPC. For a VPC in Kubernetes, it will create it in a AWS, and you will have your Kubernetes cluster. Now, anything wrong happens to this Kubernetes cluster will come back because of the controller logic. So that is the benefit I wanted to show, but I would like to move to the demo also for this one. I can take any questions also from the slides if anyone has. Yeah, so it has a provider from VMware for the bare metal, but it is not much developed. So right now I have explored the 3 public clouds. It is very much mature, but bare metal providers are not that much mature. I have also been exploring this. So there is Metal Cube and all those companies who are working on this, who are bare metal providers. But for Crossplane, actually there is a new project which I can talk. So there is a project called Upjet, which is using all the Terraform providers for within Crossplane, because it's also written in Go and Terraform is also written in Go. So it is using all the Terraform code for providers and using it in the Crossplane project. If Terraform has provider, we can create our own providers. But the thing is, that's why I think Terraform also has done this license change recently with the business source license, because Crossplane is using a lot of Terraform providers. Hmm. Okay.
VM instance of creating the VMs, right? So in that case, that can Crossplane can help me to manage my infrastructure from the VM perspective, because VM itself inside running inside the Kubernetes cluster using the KubeVirt.
Okay, so let's say that in that scenario, we will not use a managed solution like EKS. We will need to have just EC2 instances running, right? And that on top of that, we can install some custom controllers like KubeVirt to run VMs inside Kubernetes, right? So I would suggest that one approach to do that is to use the EC2 API instead of EKS API. Here I'm just talking about the managed solutions, EKS, GKE, AKS. We can create EC2 instances, but I think
Crossplane support that, right?
yeah, Crossplane has for EC2 also. Yeah, but a better tool in my opinion is Cluster API in that, because Cluster API separates infrastructure and the management, the bootstrapping. So let's say if you want to use an older version of Kubernetes and you don't want to bootstrap it using kubeadm, that is not supported in Crossplane because it follows all the, it will just give you the EC2 instance. You have to manually do some Ansible thing to bootstrap it. So Cluster API has everything for it. You can check that out. Thank you for your question. Okay. So let me just go to my terminal. Is it visible in the screen? Okay, thank you. So here I have a Kubernetes cluster here. Right now this Kubernetes cluster has some pods running, so I might just show them. Okay, so I have installed Crossplane in it, and Crossplane is working in these two pods will come up in Crossplane, and there is some provider also running, provider AWS. This is using the provider family, which is the latest from Crossplane to avoid the overhead, because custom resources in Kubernetes are, if you create a lot of them, then there will be like Kubernetes performance will be degraded. So those are some of the things that are running. Apart from that, I talked to you about the custom resource definition and the composition. So I have written some manifest and created some custom resource definition, which is also available in the GitHub. So this is one composition called X cluster, which helps me with all the managed resources combined into one YAML file. And it has everything like node group, whatever I think my opinion of a Kubernetes cluster will be, like some node groups and then VPC and then some IAM roles, and whatever I might need to add, I will add them and call it a composition. And first I will define a XRD, which is composite resource definition. So in this XRD, this is just some metadata. The main useful information is what will be required from my developer. So as you can see that some mandatory fields are like region, Kubernetes version, node size, and min node count. So these are the stuff that you can define, and a file like this would work. Finally, from the, let's change my hat. I am a developer now. So to avoid all the complexity, I have to run a similar, I have to create a similar file like this. This file has the capability to give me a Kubernetes cluster in EKS without me knowing any of the best practices of VPC or security or IAM. So let's just see my AWS console for a minute. So I have a clean AP South one, no EKS clusters running. Yeah, no VPC is here also. The default VPC is there. So let's just ask Crossplane to create a Kubernetes cluster. I will go to the terminal, and as a developer, I have this manifest here, this one, and I will just apply it. Okay, so it has said that something is created. So if you want to see all the managed resources, the singularities of that composition, you can do a kget managed here, and all the managed resources will be listed in a Kubernetes cluster, still in the Kubernetes domain. So as you can see, some have said that it's ready. Ready is true, because if you see, IAM roles will not take much time to get created in AWS, but a container takes time in Kubernetes. Similarly, a EC2 instance takes so much time to come up. So till that time, Crossplane will keep hitting the API and see if the ready state is achieved or not. So normally AWS takes like 10 to 15 minutes to get created, but I just want to show today the concept that is happening. So you can see that some things are getting true when I do this command again and again. Let's say this subnet is being created by AWS, depending on the cloud provider totally. Civo can get this for in 1.5 minutes to you, and all the things are happening. And I would also like to show you from the AWS realm also. Equivalent VPC would have been created here, which is this devconf EKS VPC, and some networking components it will have, like the subnets and everything. Yeah, you can see the route table and everything. All the things are there. And finally, when everything is created, the roles are created, it will start creating the control plane. Right now, it has not achieved that state. Some subnet is pending. Yeah, so the cluster is started to create, but it will take like 10 minutes. I didn't plan this session that well. I wanted to show deploying an application also, but I will stop right now and I will take any questions which I have for me. Yeah.
So my question is regarding this. The same thing can be achieved using Terraform as well, right? So my question is like in case of Terraform, we have a provider version to be kind of sync and map with what my version which I'm using, right? In case of AWS API, uh, is there any chances that the Crossplane would throw the error, right? Because like something has been changed from the AWS API perspective. Do we take care of that in the Crossplane in terms of updates which is happening in the change or new features being launched? For example, S3 bucket management or policy of the S3. There are a lot of things which quite happens very fast, right?
Correct.
So who manage it and who take the
Okay,
responsibility?
so Crossplane is a donated project to the CNCF. It has lots of maintainers, and as AWS matures, AWS changes their API. The Crossplane provider has also needs to be changed, and a lot of developers are doing active work to maintain it, just like Terraform. So all the APIs keep changing, and there are always changes. So I am also using a stable version of this EKS provider, but it is constantly being managed.
Okay. And there are two different YAML file you have shown, right? One the platform team will manage, one the developer will manage. So what I see the difference, the uh, the content of that YAML file when the developer will spin up the EKS, it's very small, right?
Correct.
And for the platform, it's very large, right?
Correct.
So, like, what are the documentations or what are the things that a platform team and SRE engineer need to take care while writing those long YAML files? And I wanted to see the understand the structure and also the documentation if you can show it.
Okay, so actually, the way to handle this is a lot of teams, like today, platform teams composed of security people also, and a lot of core infrastructure people, and then some SRE principal, observability people also, right? So everyone can implement their solutions, their best practice guidelines, and it is up to the platform team's idea, like what I need to include. So for example, for my requirement, I needed to have a EKS cluster running with some IAM roles which are required for my EKS cluster to run, like some control plane IAM roles, and also the best practices. So for example, if I give you an example, here I have created a VPC with 2 subnets, but there will be a possibility that somebody might require a 3 subnet or multi-AZ deployment, right, for their production Kubernetes cluster. So if I wanted to create an abstraction, I could use some patterns here to make that variable thing. Like you can choose your own subnet. You can give in that dev file that 3 subnets are needed. So accordingly, your complexity increase in the writing this composition file. But because the idea was to create a simple abstraction for a Kubernetes cluster, EKS cluster, that is why I have chosen to make it simpler. But the more you increase the complexity in the devs area, that file becomes longer. If you see here, more and more things will be adding, and composition also will start increasing. So this is a starting point for practicing platform engineering in organization, but this will evolve, and similar approaches can be followed. Actually, there is like for Terraform also we can do GitOps. ArgoCD has complete integration.
No, I mean, you have actually in your first slide was very contradictory for the many people because it talks about like from the ISC perspective, right? Like Terraform is not meant to be for that purpose, right? Like Crossplane is solving that problem. So at the end, we would have this everything a GitOps managed, right?
Correct. So
Especially this
today
library.
I did kubectl apply, which is wrong. I should have deployed a Argo CD and then pushed this configuration to a Git repository and then had Argo CD reconcile that. That is the correct approach. But for the demo purpose, I did a kubectl apply. So GitOps completely goes against kubectl because it's a CLI command. So this file sits in a Git repository in the final state.
Okay. Thank you.
Thank you so much for the question.
Is there any CLI support to generate all these manifests that you showed for this custom resources? Or
No.
any ID support that we can take help? Because this YAML was quite complex and
Okay.
big, right?
There is a CLI support. Crossplane has a CLI. I don't use it. I use the kubectl because Crossplane is itself installed in Kubernetes. So it is just a controller. So just like ArgoCD is installed in Kubernetes. So mostly you don't want to use Argo CLI. You will use the kubectl only to deal with the applications and all the similar to that Crossplane. But there is a CLI with Crossplane, but it doesn't help you create this manifest, but it helps you render this, test this manifest actually. So whether I have the right YAML specification or not, whether the composition structure is correct or not, you can test that using Crossplane's render function, render command, but you cannot generate this manifest. But there are numerous help pages available for Crossplane. It is being maintained by a website in which you can push the packages. There you can get a lot of documentation which will give you even the sample code to write this manifest. Thank you.
Thanks.
Any more questions for anyone? I guess not, so I think we are good.
Okay. Thank you so much for being a good audience.
Okay, so the next session we have is from Swaraj Pandey, who needs drama when you have Rama Lama. We have around 10 to 15 minutes break now. Post that, we'll be resuming the session at 4 o'clock.